Hello, this lesson is for Chapter 11, Sampling Distributions. First of all, what do we mean by a sampling distribution? So here's the definition I'm going to give you. It's a distribution. Remember, a distribution is like a histogram or box plot or something. It's a distribution of all the values of a particular variable. So a sampling distribution is a distribution of all possible sample results from a random sample. Okay, first a little bit of vocabulary. So you already know about population versus sample, but let's talk about population mean here for a minute. A population mean is the mean of the entire population, and we will use the Greek letter mu to represent population mean. We also have the sample mean, which is given by the normal the x bar, which is what we normally have been using for the mean, but now it's specifically only for a mean that's coming from a sample. And then we have population standard deviation. I'll just do SD for standard deviation, which is given by the Greek letter sigma. And then we have sample standard deviation, which is given by S. Now, the idea here is you have some population, whether it be the population of fish in the ocean or the population of people going to college or whatever. All we have to go on is the mean from the sample, and then we want to use that mean from the sample to estimate the mean of the population, because we're not going to know the true population mean in very many cases, but we have to estimate the best we can. And so how good can the estimates get, and can we come up with ways to measure how reliable a particular sample mean is? That's what Chapter 11, Sampling Distributions, is all about. So to begin, let's suppose we have a population of fish in a fish tank. It's a nice simple demonstration to get us started. So let's take a look. I have a nice picture of some fish in a tank. So here's our population. And also, let's just suppose that we know the measurements of all the fish in the whole population. So let's just pretend that this is the weight in grams of our fish. That we have. Let's say we have 16 fish in our fish tank. And here's the whole population measurements right here. Now, of course, it's pointless to take a sample of these 16 fish, because why bother? We already have the measurements of everyone in the population. But in general, we normally don't have the measurements of everyone in the population, so we take a sample to estimate the population mean. But for this first demonstration, let's just go ahead and take a sample of this population, to figure out how close our sample means are to the population. Well, first of all, just out of curiosity here, what is the population mean of these fish? Well, I copied and pasted these 16 values into Excel. Let's get Excel up here. And here it is. So I copied and pasted the values of the 16 fish, the weights of the 16 fish right here, and I used the average command. It turns out to be, I just typed in an average A1 through A16, and the population mean is 4.325 grams. Let's write that down here. So that's mu what was it? I forgot already. 325, I think it was. Yeah, 4.325 grams. Okay, population mean. And just out of curiosity, what's the population standard deviation? So that's given by sigma, which is, let's go back to Excel. So this one I hadn't computed yet. Let's go ahead and just type that in real quick here. Equal sign STDEV of A1 through A16. Okay, about 1.51. One more time, the command there, the standard deviation command in Excel, about 1.51. All right, 1.51 grams. Okay, now of course normally we don't know these numbers, but for demonstration purposes we know these numbers. Okay, so let's take a sample. How about four? Four fish in our sample. So sample size is n equals 4. So now, of course, the proper way to take a simple random sample is to give every fish a number, like call this fish 1, fish 2, fish 3, etc. And then you randomly choose the numbers. But let's just, to save some time, let's just pretend that I did that. And let's just say I picked, let's pick a different color here. Let's just say I picked this one and this one and this one and this one. Let's say those are my 4 randomly chosen fish. And let's just suppose that the measurements for those 4 fish, let's say, is this one and this one and this one and say this one. Okay, so those are my 4 fish in my sample. So how close did my sample mean of these 4 fish, how close did that sample mean get to our population mean of 4.325 grams? So let's go ahead and calculate that. So x bar equals 5.2 plus 2.1 plus 5.6 plus 4.6. Divide all that by 4. Okay, let's get out a calculator here. Let's got some old stuff here. 5.2 plus 2.1 plus 5.6 plus 4.6 equals 58.9. Divide that by 4. Oops, there's some mistake here. Okay, let's try that. Let's try that again here. 5.2. I must have accidentally pushed an extra button here. 5.2 plus 2.1 plus 5.6 plus 4.6. Okay, 58.9. Divide that by 4. Okay, the answer is 4.375. I was having some technical difficulties there. Okay, so actually this sample mean, 4.375, I got really lucky here. My sample mean is actually really close to my population mean. Now, of course, not all samples are that close, but it's actually a pretty typical result because typically when you take a sample, some of the fish will be underweight like this one, some will be overweight like the 5.6, and some will be around medium like 4.6. That's sort of a typical sample result. In this case, I got a fairly typical sample result, and so my average is quite close to the population mean here of 4.325. Now, let's go back to the definition here of a sampling distribution. So a sampling distribution is a distribution of all the possible sample results from a random sample. And so the sample that I did here, the 4.375, it was one of many possible potential samples.